Hello everyone. In the last session we have finished unit number 5, that is polarization. In today we will start unit number 6, that is space segment. Now what do you mean by space segment and what is the importance of space segment? First of all, the satellite communication consists of two segments. First one is Earth segment and second one is space segment. Earth segment, that we can also say that a ground segment, right? So communication link can be established between space and the earth. In today's session we will start the space segment. In the space segment we will cover what do you mean by altitude control, orbit control, different anatomy and different parts of satellite. Now this diagram you can see from over here, that is the satellite's internal portion. Now the red one is the solar array, which consists of solar panel, right? This is transmitter, or you can say receiver. This is high gain antenna. Why? Because as we want to transmit a signal to a longer distance, it requires a higher gain such that our signal will travel to a longer distance with minimum loss. Because a signal has traveled from the space to the ground, it has to travel through different layers of atmosphere. It will cause the attenuation and also degrade the signal quality. That's why we have to use a high gain antenna. Okay. Then processor, omnidirectional antennas, digital camera to capture the image, then bus structure, battery, thermal blanket. So over here, each and every portion is going to be identified with the different colors. Blue portion defines the command and data. It means to give a command or to retrieve the data from satellite. And power supply, pointing control, that means we have to make a specific orbit. We have to assure that our satellite will be remain in the specific orbit. So we have to make its altitude as well as its orbit control. Then its payload. Then the green one is for communication. That means it consists of transmitter or receiver, or you can say high gain antenna. And thermal control means we have to control its temperature. Okay. First of all, we are focusing on power supply. Now, what is the importance of power supply? Actually, in satellite communication, as we are placing a satellite in space and it is orbiting around the earth, that's why we don't provide any supply from AC or DC, but it can get supply from the sun. That's why the primary electrical power is called the solar cells. Okay, so solar cells, it's an array of cells in series or parallel connection which is required. Okay, so if you want to get a higher power, so it is achieved with the help of solar panel, which is arranged in the form of rectangular or solar cells, because it is capable of greater power output than a cylindrical arrays. Okay. Now, attitude control. In this chapter, that means a space segment, we are going to maintain the attitude of satellite and its orbit. So how this attitude and orbit is going to be controlled? So first we are focusing on the attitude control. So attitude means what? That means the orientation of our satellite in space. That means we are going to ensure that the directional antenna which is point in the proper direction. Why? Because our satellite is continuously rotating and our transmitter or receiver which are on the earth, that are fixed. So we have to make sure that our satellite's antenna is always pointing towards our earth station antenna. That's why we have to stabilize a satellite which having the two method. First one is passive, second one is active. Now, a passive system which is used to stabilize the satellite without putting a drain on the satellite's energy. That means if you are going to use this passive system, that it will not affect on my satellite's energy supply. So best example is spin stabilization. That means a gravity gradient stabilization which causes the interaction of satellite with the gravitational field of central body. So it will not affect the actual energy of our satellite, which it gets from the power supply or you can say solar cells. We are only going to use the gravitational field of central body. Okay. Now, what do you mean by active altitude control system? So active control maintains a satellite altitude by sensing its orientation along the three axes. Which three axes are there that I'm going to explain you in the next slide, which forms the correction based on this measurement. It has three methods. Momentum wheel, that means three axis or body stabilization. Second one is electromagnetic coils, and the third one is mass explosive device. So it consists of three components. First, that sense the current attitude of the platform. That means what is the current orientation of satellite in space. First, we are going to sense it. Then, once it computes, we are going to deviation that how many changes are there in the current attitude from the desired attitude. So one that controls and corrects the computed errors. Then we are going to compute the errors and correct it. Now, what are the three axes? The three axes are roll, pitch, and yaw. So separately for these three axes, motors are there to correct the orientation of satellite. Yaw means its orientation is towards the Earth center. Pitch means it is normal to the orbital plane. And the roll means it is perpendicular to another. Okay. Now, as sensors are used on the satellite, which is used to determine the position of satellite axis with respect to the specified reference direction. But which reference direction we are going to use? These are like with reference to Earth, Sun, or star. Okay, so Earth sensors sense infrared emissions from the Earth and used for maintaining the roll and the pitch. So if we are going to maintain this roll and pitch, then Earth sensors are used because it sends the infrared emissions from the Earth. Okay, and if we want to maintain the yaw axis, then we are going to take the reference of Sun and star. Okay, so for yaw axis measurement and control, we are going to use Sun and star, and for roll and pitch, we are going to use Earth sensor. So this is called three-axis spin stabilization, which is called the active method, which is used to control the attitude. Attitude of what? That is the orientation of satellite. Okay. First, it is going to be computed, then the error between the current attitude and the desired attitude is computed, and the correction torque is applied in proportion to the sensed error. So torque is applied through a motor, which I have shown you over here. Motor will rotate specific axis in the desired direction once error is computed. Okay, so this is a three-axis stabilization. In the next session, we will see that what do you mean by orbital control as well as transponder, and how this orbital control will works. That means we are going to maintain our satellite in desired orbit, but because of the gravitational force of sun and moon as well as the gravitational force of other planets, which will cause the deviation in our satellite's orbit. So once a satellite is moving from its desired orbit, then we have to make sure that it should be in our specific orbit. That's why orbital control will be going to be considered. Okay? As well as if you can see that the transponder. So first of all, transponder means what? As I have told you, it has a two types, active and passive. So active satellite, which will only active transponder, which receives the signal, which amplify it, and again retransmit back to the satellite, our Earth. Okay, and passive means which receive the signal from the Earth and simply reflect back it to the Earth. So there is a no amplification is done. Okay, so if we want to define that what do you mean by transponder, then we have to define it with the help of active and passive. That can be a directional or bidirectional. Okay, and if we want to generalize the difference between Earth segment and the space segment, then what does it mean? Earth segment, that means that different components which lies on our ground or on our Earth, like transmitting antenna, receiving antenna, communication link, as well as repeaters. Repeaters which are used to transmit a signal to the longer direction, to the longer distance. Okay, so as our signal travels to a longer distance, a repeater will going to regenerate the signal, because the signal as travels to longer distance, its signal quality will going to be degraded or decrease. It will cause the attenuation or the loss of my signal. So we are going to place a repeater at specific place. Okay, so that's why we have to consider what is the use of repeater. Now that repeaters, transmitting antenna, receiving antenna, these all are lies on the ground. So these are the part of our ground segment or the earth segment. If I can say, then what are the different components of space segment? So the different components are like satellite, and the communication link between satellite and our earth is going to be established. Okay, so this communication link will allow a transmission and the reception of our desired data, right? This we will discuss in brief in the next session. All right. These are the references which I have taken. You have to use a reference book for satellite communication, that is Dennis Roddy. Still, if you have any question, you can ask me at any time on this email ID. Thank you for your attention. We will cover the next session transponder as well as the orbit control system. And as we know that orientation of wave, that is the polarization that we have discussed in the last lecture, that is chapter number 5. That means it has a different types like circular, elliptical, vertical, horizontal. So these type of polarization that we have to define at the transmitting side as well as at the receiving side, such that our antennas are sensitive to the polarization of the wave. Okay, if the polarization is not matched, then it will cause the polarization mismatch loss. That we will discuss in chapter number 8, that is the earth segment. So when we are defining the earth segment, then we have to discuss all the different laws that is available in the link as well as available in the space as well as in different media, and our electronics component which itself generate a noise. Once again, thank you for your attention.